Hi, this is Mrs. Dorman. We're going to talk about inverse functions. Okay, so we want to graph the inverse of this function, the purple function that's there. So what we do is we take points on the function and then switch the x and y values. We reverse them. So an input function means you just switch the inputs and the outputs, and those functions are inverses of each other. So you take an x and y coordinate, and then we're going to switch it, switch the y on the x, and then that's how we get our inverse function, our graph of our inverse. So I'm just going to start picking points on the original function. So I see a point at 1, 4. So 1, 4 is going to become 4, 1. So we graph that for our inverse function. So I'm just going to keep picking more points. It looks like there's another point at 3, 6. So 3, 6 is going to become 6, 3. And I see a point at negative 1, 2. So that would become 2, negative 1. And also, if we're kind of having a hard time connecting the points that we have, so we have these 3 points so far, but maybe it's still just a little difficult to connect those and try to get a sketch of what the inverse function would look like. So we could just keep picking more points, which I will, but also a function, when it reflects over the line y equals x, which is this green line that I am graphing. So when it reflects over that line, it becomes the inverse function. So when we connect the points, it should look like, the purple one should look like a reflection over that line in order to get the inverse function. But I'm still just going to pick a couple more points that might make it a little easier. So I see a point at negative 2, negative 3. So I'm going to go to negative 3, negative 2. And let's say I do one more. How about, it looks like on the original one, 4 over 4 and up, like 10 and a half. So 4, 10 and a half. If I switch that, I get 10 and a half, 4. Okay, so I feel like that's enough for me to be able to connect the points. Again, if you're not sure, just keep picking more points on the original one and switch them so that you get enough points for the inverse. I'm going to connect these, and that's what the inverse function looks like. So we take coordinates, switch them, switch the x and y values, and that's how you get points for the inverse function. Just keep picking points until it gives you enough to be able to connect the points and be able to sketch what the inverse function looks like. And also, when we look at the purple graph and the red one, which is the inverse of the purple one, it looks like a reflection over the line y equals x. Okay, so for these ones, we want to evaluate some points for the function. So for the first one, it says we're going to use this table to find f of 4 and the inverse of f of 4. So when it just says f of 4, that means x is 4, and we want to find the output when x is 4. So I go to my table, x is 4 here, and the output is negative 2. So f of 4 is negative 2. The next one says the inverse. So the way you read this with the little to the negative 1 is actually the inverse of f of x. So this would be the inverse of f of 4. And inverse just means you switch the inputs and outputs. So instead of plugging in 4 for the input, you put in 4 for the output, which happens here, and you put what the input is. So that would be 9. And the next one we have a graph. It's the same idea, though. We're just reading the graph instead of the table. So f of 2, and actually these should say g of x. These were supposed to be g's. So just pretend those are all g's. G of 2, and that means I'm plugging 2 in for x. So I'm going to the graph and I'm looking for when x is 2, and that's here. So I'm going down and figuring out what the y value is. So this is when x is 2. And I'm just going down and going to the curve and figuring out what the y value is when x is 2. That point is at 2, negative 6. So then g of 2 is negative 6. And then the inverse of g of 5 means we're going to do that backwards. So instead of plugging in 5 for x, I'm going to go for when 5 is the output, the y value, and go over to the curve and figure out what the x value was to get that y value. So it looks like about 4.5. So the inverse of g of 5 means that you're putting 5 in for the output, that's the y, and you're figuring out what the input was to get that y value. Okay, so for this one we want to write the equation of the inverse, and I'm going to look at the original function, and it says in this original function you take x, when you plug in a number for x, you take x, you subtract 4, so I'm thinking about what operations are done in the original function because the inverse function needs to undo all of those operations. So in the original function, the order of operations are you plug in a number, when you plug in a number for x, you subtract 4, and then you would get whatever value that is and square it. The next thing you would do is square that number. So order of operations, say you do the parentheses first and then the exponents, and then you multiply, so then you would multiply by a half. And then the last thing would be this adding 3. So the inverse function needs to have inverse operations from the original function. It needs to undo all of those steps, starting from the last step that happened. So instead of adding 3 at the end, the first thing we would do for our inverse function is subtract 3. And I like to just kind of start writing the inverse function while I'm thinking about these steps. So in our inverse function, I'm going to put the inverse of g of x. We should be taking x, and I'm leaving some space because I want to build onto this, taking x and subtracting 3. So now I'm going to go up on the original function. I just did the adding 3. In the inverse of that is subtracting 3. So now I'm going to go up one step from that, and the inverse of multiplying by a half is dividing by half. But that's the same thing as multiplying by 2. I don't usually divide by a fraction. The way you divide by a fraction is you multiply by its reciprocal. So I'm going to keep building on my function down here. We already subtracted 3, now we multiply by 2. And now this step is taken care of, so I'm going to go backwards again and look at the squared, the inverse of squaring. In order to undo squaring, you take the square root. So then I'm going to go down to my equation and take the square root. We've taken care of the squared step, and then the last step for our inverse is going back to the first step of the original function. The first step was subtracting 4, and the inverse of that is adding 4. So then in my equation, I'm going to put the end plus 4. Okay, so now I want to look at this extra little thing that was in my original function, and that meant it was restricted to be only numbers that were less than or equal to 4. That means in our answer, we're going to put a negative in front of the square root. And I'm going to draw a little graph just to explain why, and I'm going to making just a little bit more room here so the negative fits. So we want a negative in front of the square root. I'm going to graph it just to explain why. So I'm going to graph the original function, g of x, 1/2 x minus 4 squared plus 3. So it's a quadratic, it's a parabola. It's vertically compressed by a half, and it's shifted to the right 4 up 3. So I'm just going to sketch it. So here's g of x, and then so we can picture what the inverse looks like. I'm going to reflect it over the line y equals x. And what we're going to end up with is like a sideways parabola. So if I just start taking some points on the original and switching x and y, then I'm going to get what the inverse looks like. And I'm going to come back to this part, the less than or equal to 4, in a second, and explain why we need just less than or equal to 4. So if I take the vertex of the parabola for 3 and just switch that to be 3, 4, I'm going to point there, and I'm just going to keep picking some other points and switching the x and y values. Okay, so this is what I end up with, and the problem is that's not a function. It doesn't pass the vertical line test. There are multiple inputs that have two outputs. So the reason we want to restrict the original function to be just half of a parabola is so that the inverse is a function. So the less than or equal to 4, this part that x is less than or equal to 4, means for the original function we only wanted the half that's less than or equal when x is less than or equal to 4. So we want to erase all of that part of the parabola that was greater than or equal to 4. So we just have that half of a parabola. I'm going to go back over it so we can see it a little better. So it starts here at 4, and we just want the part of the parabola that's less than or equal to 4. So just half of a parabola. And then that means when we do the inverse, we end up, if we only do the inverse of that part, we end up with just this lower half of this red curve, this kind of sideways parabola. And we wouldn't have this top half at all. When we reflect that blue half of a parabola over the line y equals x, we just get that red curve, that red part, which is just a negative square root function. So basically any time the original function, the original parabola, has like a less than or equal to symbol here, we're just going to put a negative in front of the square root. If it has a greater than or equal to symbol, then we're going to just leave the square root to be positive for our answer. Okay, let's try another one, but this time it's a cube root, or it's a cubic function. We're going to end up taking a cube root. So again, I'm just going to start listing the operations in the original function. So if we were plugging in a number for x in the original function, we would add 1 to it. You would get a number in here in the parentheses, and then you would cube that. Then you would multiply by the 2 in front. And at the very end, subtract 3. So that's the order of operations in the original function. So then we're going to go backwards and undo all those for our inverse function. So instead of subtracting 3 was the last step for the original, the first step in our inverse should be adding 3, add 3. And again, I'm just going to go ahead and start writing the equation of the inverse as I go. So the inverse of f of x, I'm going to leave some room, but the first thing is you take the input and you add 3. And then instead of, I'm just checking off that we did that one, I'm going to go backwards. Instead of multiplying by 2, the inverse is divide by 2. So that takes care of that step. And in my function, I'm going to put divided by 2, or you can multiply by a half, that's the same thing. And then I'm going to go back one more step, and instead of cube, we take the cube root. That's the inverse of cubing, is taking the cube root. So cube root. And then the first step in the original was add 1, so the last step in our inverse is subtract 1. So then just on my function, I put minus 1. For cube root, we don't have to worry about putting like a negative in front of the cube root, and there's no restriction in the original function. The original function is a cubic, and our inverse function is a cube root function. Okay, one more problem. We're going to write the equation of this inverse. I just have this graph here. We don't have to graph it, but I want to just show kind of on that other problem, like what's going on when we find the inverse of this square root function. So I'm going to do the same thing I did with the other problems. I'm going to list out the order of operations in the original. Okay, so the original function, we would add 5 to x, we would take the square root, and then subtract 2. So if we were plugging in a number for x, this is what we would do to that number. And then for our inverse, we're going to undo those steps. So instead of subtract 2, add 2 for the first step. And I'm going to go ahead and start writing the equation. The inverse of g of x. I'm going to leave some room in case I need to add to it. We're going to take the input and add 2. I'm just writing the first step down. Okay, so that took care of, that was the inverse of subtracting 2. Now we're going to do the inverse. We're going backwards. Do the inverse of square root, which is squaring, square. So then in my answer, I'm going to take the x plus 2 and square it. And then we're going to go backwards again. The inverse of adding 5 is subtract 5. So I'm going to put a minus 5 in my answer. So we're running into the same problem as the problem 2 back, where we had a quadratic. We started with a parabola, and then we ended with a square root function. This one we're starting with a square root function, and we're ending with a parabola. But the reason I have this graph here is I just want to sketch what's going on because our answer isn't quite finished. So in the original function with the square root, I'm going to sketch what the square root of x plus 5 minus 2 looks like. Okay, so this is a square root function. It's been shifted to the left 5 and down 2. This is g of x. And then if we graph the inverse of that, which means we're going to take the x and y values and switch, or the coordinates and switch x and y, we'll end up with half of a parabola. And so we need to figure out like what half of the parabola we end up with. So if I just start taking points and switching the x and y, for example, the square root function starts at -5, -2. So if I just switch that and make it -2, -5, I could also just look at my inverse function here and start graphing that. So it's a parabola that's shifted to the left 2 and down 5. And then I'm just going to keep taking more coordinates, like negative, in the original one, there's a -4, -1. So if I go to -1, -4, I get a point. There's a point on the original at -1, 0. So I'm going to go to 0, -1. Okay, so this is what the inverse is supposed to look like. But if I graph the inverse that I wrote, that's a whole parabola that looks like this. But I don't want that whole parabola. I just want the right side of the parabola that I originally had. I just want that part. So then in my answer, I need to restrict the domain. That means I need to add something to it that says I only want the half of the parabola that's greater than or equal to wherever the parabola like started from here, this line, -2. And that was just wherever the horizontal shift is. So this was shifted to the left, -2. That's going to be the same number that's there. And I want greater than, I'm just double checking greater than, that matches that this was a positive square root at the beginning. So this would be my final answer for the inverse. I have a quadratic function, but I only want half of the parabola. I want the part that's greater than or equal to -2. The -2 comes from wherever it's horizontally shifted. It's shifted to the left 2, so that's why this number is a -2.